Welcome to the fifth film in our Foundations series, in which we discuss what happens at the point where the foundations meet the ground. As well as transferring loads into the earth, the part of a building that comes into direct contact with the ground must also perform certain other functions. Water is a building's greatest enemy. While it's obvious that the parts of a building above ground need to be kept dry, water ingress below ground level can also have serious consequences. Potential problems range from ground moisture via percolating surface water and standing water on non-permeable strata to potentially dangerous temporary increases in the groundwater level. As a result, buildings must also be protected against groundwater. In Germany, the techniques for dealing with groundwater are set out in two important standards, DIN 18533, waterproofing of elements in contact with the ground, and DIN 18195, waterproofing of buildings, terms. DIN 18195 sets out the terminology of waterproofing or damp-proofing and so serves as a sort of glossary. DIN 18533 describes the various types of problems that may occur and the corresponding solutions. DIN 18533 starts by classifying the various ways in which groundwater can affect buildings. These water exposure categories describe a series of situations and specify the type of waterproofing to be used in each of them. While ground moisture and non-pressing water are harmless, pressing water at an immersion depth of more than 3 meters can be highly problematic. The soil survey indicates which of the water exposure categories is present on a given site. The standard also sets out 3 spatial use categories that are subject to low, standard and strict waterproofing requirements. The requirements for this car park at our Wolfsburg site, for example, are low, while those for the foyer of the Nordkopf Tower fall into the standard category. More sensitive uses, such as the storage of archive material, for example, are subject to strict requirements. The standard also makes specific reference to one very obvious rule. Foundation elements that are in contact with the ground must be waterproofed on the side facing the water thread. This makes complete sense. You wouldn't dream of putting socks on over your rubber rain boots, for example. There is, however, one exception to this rule, which I'll tell you about in a moment. First of all, though, there's something else that I would like to mention. Parts 2 and 3 of DIN 18533 distinguish between different types of waterproofing. The parts of a building that are in contact with the ground can be waterproofed using either sheet materials or liquids. These measures can be quite rustic, as you can see here on the waterproofed exterior wall of the old building in Wolfsburg, which adjoins our new building. The viscous layer of bituminous sealant originally applied to the wall had to be interrupted when an opening was subsequently made from the old building to the new. This diagram from DIN 18533 shows the simplest type of underground waterproofing. The groundwater level is more than 50 centimeters below the bottom of the foundation, and rainwater is able to seep away quickly because the ground is very water permeable. This situation involving non-pressing water is defined in water exposure category W1.1e and provides the exception to the rule that I mentioned earlier, which states that waterproofing should always be applied externally. Reinforced concrete foundation slabs in this category can also be waterproofed internally. This figure shows a far more serious case. Category W2.1e describes a building whose foundations are always in the water. Apart from the risk, which I mentioned earlier, of the water pressure causing the building to lift, there is also significant pressure on the waterproofing material. When pressing water is involved, as here, the waterproofing needs to be much more effective, and so either white concrete tanking or black tanking in the form of a waterproof membrane are used. The same principle applies in everyday life. Not all raincoats keep you dry, but water never seeps through your bath. Waterproofing is fitted in the working space between the edge of the foundation pit and the exterior basement wall and must be protected to prevent it being damaged when the working space is backfilled. This can be done by means of a drainage plate, for example, which also improves drainage around the building. If the building is heated, thermal insulation, known as perimeter insulation, is fitted externally. Additional functional layers may also be laid on the foundation slab. If the ground is impermeable or only slightly permeable to water, the working space should be backfilled with a permeable material. This prevents water from backing up against the exterior basement wall and pressing on the waterproofing. Here you can see how the working space in Wolfsburg was backfilled with water-permeable gravel. The natural ground to the right of it is less permeable. If there is a danger of seepage water backing up around the foundations, then land drains will be laid. These are perforated pipes designed to collect water that are run around a building. The water that they collect must then be diverted away from the building and allowed to run away in a controlled manner. Summary. Buildings have to be protected against groundwater. German Standard DIN 18533 deals with the waterproofing of elements in contact with the ground. Its water exposure and spatial use categories specify the types of waterproofing available and where to use them. We recommend that you take a look at the 6th film in our Foundations series, in which we consider the information that needs to be included in a foundation plan.